We are live.
Nice.
Cool. I'm sure that a few people that have come to all the sessions so far will be sick of hearing me say this, but we'll just wait a couple of minutes at the start of this just in order for people to join. Numbers are flying up quite quickly, probably quicker than any other day, which bodes well given it's a Friday. Thank you so much for everyone attending on a Friday. Hopefully everyone has plans to go do something Halloween-y after this. Nikki, have you got any plans?
I do not have any Halloween plans right now, to be honest, but we'll see where the weekend takes me. How about you?
Nice. Well, I have my 4-year-old niece and my 2-week-old baby. Baby is currently dressed as a pumpkin. Niece is dressed as a spider, which was a weird one. I said to her she doesn't even like spiders, and then she went, I don't. It's like, why are you dressed as a spider then?
Well, if she's scared of them, then she's being scared of Halloween.
I guess so. So yeah, I'll be spending the evening with them. I might put on a scary movie, but because she's 4, scary movie is probably more like a Goosebumps than anything else. So yeah, it won't be anything.
Can't go wrong with a Goosebumps, mate.
Exactly. For today's session, for the people that have joined so far, we'll be going through data today, data landscape. So we'll be going through data engineering, data science, and AI. Hopefully some people have been part of all of the sessions this week. From my understanding, there's about 20 people that are currently eligible for the wine tastings. They've been to every session. So I'm expecting that a few of the people in this session right now are probably part of that. But it's going to be good to see a few of you on there. And I think let's get started, and then we can crack on. One sec. I just thought, I don't know if I've downloaded the thing. Bear with me. Let's wait for that. I'm going to export. Nikki, can you see that's the wrong one. Always good with the power of technology when you can't get the right ones come up.
It's always a way.
Can you see my screen now?
Yeah, perfect.
Cool, amazing. Sorry for everyone at the start of that. Good start. So what we're going through today is an introduction to data landscape. We'll be looking at data science, different types of data methodologies, then what is the difference between data science and how it differs to data engineering, a look at data engineering, and then an introduction to AI. There usually is the recruiter insights at the end. I've only put 4 slides on here because it's already a 33-slide presentation, so there's a lot of content we need to get through. There may be bits that we touch on shallow level today, but you'll be getting all the content afterwards, just to make sure we get through all this content, because especially AI is very, very interesting, so I want to make sure we get to that. Cool, so let's, 1 second, because that's cut off some of my screen. So what is big data? So let me zoom out a little bit. So basically, big data refers to when there is a data set that's way too complex for traditional methods, i.e. computers, to be able to process and store that amount of data. So it's a term that doesn't actually refer to any amount of data. It's just the amount of data that is too big for a computer. That could be anything from a terabyte up to a zettabyte. So it's got quite wild in terms of its terminology now, but it was coined in 2000s by an analyst called Doug Laney, who defined it by the 3 V's. So 3 V's are looking at volume, So organizations collect data from various sources. So looking at transactions, if you maybe are an e-commerce website, any kind of IoT devices, videos, images, etc. So that's the volume. So it's looking at how much volume are you putting through and how much does that cost from a storage perspective. Velocity. So as we went through the growth of the Internet of Things, data streaming in businesses grew at an unprecedented rate. So what we're basically looking at here is how much and can you store this and divide it into a timely manner from a velocity perspective, and then variety. So data now comes in many different forms. So you get structured data, you get numerical data, you get unstructured data, and we'll touch on relational and non-relational databases a little bit in this session, but also in Monday's session. But it comes in such many different forms now that that's what we're essentially talking about. So that's the 3 Vs. There are 5 Vs, but this is the easiest way to understand it, and really to the conversations that you're going to be having with candidates from a data perspective. It's probably the 3 Vs you need to understand. So this gives you a bit of an idea about the amount of data that is going on in the world. So in 2010, there was 2 zettabytes of data that was being utilized on a yearly basis. By the end of 2025, they think that'll be 181. So there's been a huge explosion in data. And if you look at what a zettabyte is, it's basically 1 billion terabytes. So think about all the storage you have on your Mac or on your laptop, and then think about it as 1 million times probably what you've got there, billion times, sorry, and then think about it 181 times that. So there's a lot of data going on a daily basis. Your phone has basically become a little powerful computer. It's more powerful than computers from 10 years ago. So these are the roles that you'll generally see in a typical data team. Depending on how complex your team and how modern the data engineering team is, you may not have all of these in here. So we'll touch on data engineering and data scientists a little bit later. But I think when you're looking at data analysts and data scientists in comparisons, we don't really touch on that in this presentation. A data analyst is really looking at the past, whereas a data scientist is looking at past data, but they're also starting to predict the future. So they're thinking a little bit further. A BI developer is looking at basically maintaining visualization tools, dashboards, etc., and making sure the data is in a somewhat of a form that is utilized. And then a database administrator is doing what it says on the tin, and they're doing administration tests around the database to make sure that there aren't any bugs or anything that's going wrong on that side. We tend to see nowadays that data engineers pick up a lot of the tasks that data administrator would do. So those roles are starting to go away in a lot of organizations. But if you are looking for database administrators, they are becoming very, very hard to find because it's a bit of a specialized task now and you don't see as many of them out there. If we look at the layers in a BI system, so you've got the data source layer, which has got the databases, the cloud storage, any third-party data, and then the separate files, and that's where you'd be getting the extraction. So you'd be extracting the data from these areas, and then you get to the warehouse layer, which is where you do your data transformation and the loading. So you would have your database and your data warehouse within these areas, and you have your reporting layer. So this is where you get stuff like ClickView, Tableau, Power BI. So looking at visualization tools so that if I'm a data scientist, I can present this back to a business, what's going on. So maybe we're looking at Amazon, and Amazon want to show their predicting data that if you buy a mouse, you're likely to buy a monitor or something like that because they're associated items. So you'd be using different tools and different dashboards in order to show that. So there's a couple of key tools and tech to be aware of. There's Hadoop, which is an open source framework. It's used to store and process large data sets, ranging anywhere from gigabytes up to petabytes of data. There's Pig, which is a programming language. So think about Pig in the same way that you think of Java in some ways. It's just a specialized programming language specifically for data science. There's then TensorFlow, which is an open source software library or framework, which is used specifically around ML and artificial intelligence. And then you get the non-relational NoSQL databases. So if you see NoSQL, we're talking about non-relational databases. And what a non-relational database is essentially a database where the data isn't stored in columns and rows. So if you look at an Excel spreadsheet, that will be rows and columns. So that'd be similar to a relational database. A non-relational database, nothing is held together. It's all unstructured data. And the reason you do that is you might want to just pull one part of the data set rather than pulling everything. If you're working in a relational database, in order to pull one subset of data, you would have to pull an entire row or an entire column. And then the picture on the left-hand side gives you a bit of an idea about what data scientists will be doing in very, very basic form. So customers bought this item. Also, you would expect them to buy this item because it's a shoe. You wouldn't expect them to buy a left shoe, but not a right shoe. So what does a data scientist do? On the left-hand side, when you get this deck, I would read through this in a little bit more detail because it will give you some indication. But at a very high level, what a data scientist is doing and where they sit in the business is they will be working both from a technology perspective, but they're very, very business facing. So you probably know it within your own organizations if you've worked with data science managers before. They tend to be some of the easiest managers to be able to get information out of because they're used to dealing with business side information. So they are presenting back to stakeholders on a weekly, daily probably basis what the business needs are or the customer needs are based on the data they can see. So they'll be doing exploratory data analysis, they'll be building models to measure results. They'll then be making adjustments based on these outcomes, and then they'll repeat the process from there. As I said with DevOps engineers yesterday, what a data scientist is essentially doing is putting themselves out of business. They're putting themselves out of a job over time. That's the whole point of a data scientist, because they are building predictive models, which mean that you don't need a data analyst in the future to analyze your models because it's already been analyzed itself. There's a couple of different types of data scientists at a very high level. You get the vertical experts. So that might be someone that maybe has got an expertise in, let's say, banking or finance. So they're used to dealing with data from that perspective. You get the dabblers that probably touch on a little bit of everything, do a little bit of ML, do a little bit of AI, do some visualization and dashboards. They're looking at past data and present data. You get the ML engineers that are focusing specifically on machine learning, and we'll touch on machine learning later on in this. You get a statistician, so these generally will work at a hedge fund, so they're focusing very heavily on the stats part of the business. I think generalists and dabblers are a little bit the same. They kind of touch on everything, but they don't master anything. But they're very, very good in a organization that is maybe 50 to 100 people because they can do a little bit of everything rather than necessarily being an expert. As you get bigger, you probably have people focusing on each different area. Data science managers are very, very interesting because I think some of the best data managers we've ever worked with at hackajob side are people that haven't necessarily come from a data background but have an appreciation for it. So a lot of data science managers tend to be software engineering managers that have moved into data. I think over time, and as that market starts to mature, and we're already starting to see it, you will then see a lot of people that maybe started in data science 10 years ago moving into data science and moving into data science director roles. And then you get the legends. So legends can do a little bit of everything. So they got an expertise in a vertical, they can do ML, they can do AI, they're good at stats and great mathematicians. These are very, very rare to get. I think the other way that I've seen them referred to before is wizards. And these tend to work at that tier one kind of FANG business. So you don't get many of those that are out there in the market. So they're really, really hard to find. Some of the key technologies, so if we're looking at data acquisition and data cleansing tools, you're looking at Talons. So data acquisition, getting the data from a source, and then cleansing it, putting it into a form that is readable, business worthy. Visualization, so most commonly you're looking at Tableau, but as I touched on earlier, ClickSense, ClickView, Power BI, and Looker are the main ones that you'll see from that perspective. So the dashboards that you're presenting to a business. ML frameworks, touched on this earlier, but TensorFlow is the main one. You might get Keras, you might get PyTorch if you're specifically focusing on Python for PyTorch. Frameworks we've kind of already touched on. And then from a cloud technology perspective, as mentioned yesterday, AWS is the most common, but I think that my prediction, and let's see how well this content holds up in 5 years' time. My prediction is that GCP will overtake Azure in the next 5 years and become second, and then it's going to be interesting to see how much catch up AWS. But GCP are pushing very, very hard on their cloud technologies at the moment, so I think it's likely it will start catching up, if not getting to parity. From programming language perspective, most common one is Python, but you also use Java and Scala fairly often. I think of the roles we work on at hackajob for our clients, we probably see about 60% of them in Python, probably 20% of them are open to Java, 20% of them to Scala. But Java and Scala are very, very similar languages. So generally, if you're looking at Java, you'd look at Scala or Scala to Java, whereas Python is a little bit more specialized. From a non-relational database perspective, MongoDB is the most common one. And I think we also see that across software engineering as well, with the MERN frameworks and ways of working. And then you get cluster computing frameworks, which is mainly Spark. What cluster computing is basically setting up a number of computers to run in correlation, so they're all doing the same thing, and it's pulling into a single node. So it's doing exactly what it says on the tin, where you are pulling all of the power of a couple of computers together, or tens of computers together, to run a search. The easiest one from a data methodology perspective to understand, I think, is probably predictive modeling, because you can associate it with Netflix. And most people have used Netflix, Amazon, or they've used Disney Plus before. So what predictive modeling is, it's a statistical technique to predict future behavior. So maybe I've clicked on Love is Blind on Netflix, and then it's given me chick flick movies afterwards, because it's saying, okay, if you like that, you'll probably like this. And Netflix is terrifying to me at times, because I can never get through a program because there's always something new it's recommending to me. So that's essentially what predictive modeling is. And I think we touch on recommendation engines later as well, but it's basically a form of data mining which analyzes historic and current data in order to understand and model what you're likely to do in the future. Linear regression is basically, it's very statistics-based modeling methodology. So it looks at the linear approach of modeling and sees what relationship will go on. So as we, from a beer count perspective on this one, so as we go through more months, because you would drink more beers, that's the linear regression, so all go in one direction. So it's looking at kind of responses and then explaining variables over time. So you probably could predict that over time you would get dots here or there. I don't know if you can see my mouse, Nikki. You can find? Oh, awesome. So you might see that certain months there's more beer consumed, and then certain months there's less beer consumed. But over time, you'd expect there to be a graph that goes along here, and it predicts at the end of it what you would get if you followed that pattern. Decision trees. The best way that I always describe decision trees is a little bit like I quite like this one here, but I think the other way to look at it is weather. So is it gonna rain? Yes. Bring an umbrella. That's a kind of decision tree. But if you did it from this side, you could look at it from the root side to say, right, okay, what is the animal? Is it short? Yes. Yeah. Is it short? Yes. Can it squeak? No. It might be a squirrel. So it's saying, right, okay, if this is true, this is where it's likely to go. So it's predicting stuff based on inputs from an individual, from an organization. So it puts weight to whatever actions or whatever assumptions it makes. Naive Bayes is a probability algorithm. So it's looking at certain tags and certain text to make an assumption on what it's going to be. So look at some text here to say a great game, and then the tag it would assume it to be would be sports. So this is like sports and non-sports. The election is over, doesn't really have a lot of correlation to what you'd expect from a sports side. So it's going to predict and tag it as not sports. And then Nikki, I think this is yours.
Yeah, thank you. So how does data science differ from data engineering? So a data engineer will develop, construct, test, maintain architectures such as databases and large-scale processing systems, whereas a data scientist will clean, massage, organize big data and perform descriptive statistics and analysis to develop insights, build models, and solve business needs. So essentially, a data engineer will prepare the data so it's usable. Data scientists will then take that data to generate insights that will help the business need. If we just go to the next slide. Awesome. Yeah, so in terms of daily tasks, there's huge differentiators in terms of what a data engineer does on a daily basis and a data scientist. We will send this deck over following this presentation, so I won't go through every point, but just to highlight a few. So a data engineer would ensure that architecture will support the requirements of the business, discover opportunities for data acquisition, and develop data set processes for data modeling, mining, and production. Whereas a data scientist will spend time conducting research to answer industry and business questions, leverage large volumes of data for internal and external sources to then answer that business, and employ sophisticated analytic programs, machine learning, and statistical methods to prepare data for use in predictive and prescriptive modeling. So as you can see, again, the data engineer is really focused on preparing that data so it's usable, whereas the data scientist is actually then using that data to gain insight. And, as Darren said earlier, maybe look at the past and then predict what may happen in the future. We just jump to that next slide, please. Awesome. Yeah. So what does a data engineer do? So data engineers make sure that the data organization is using is clean, reliable, and prepped for whatever use case may present themselves. Data engineers wrangle data into a state that can then have queries run against it by data scientists. And you can see on the left, it's talking about ETL, which is extracting, transforming, and loading. So the data engineer would extract the data from a data source, transform it into something that's usable, and then load it into a database for a data scientist to then go and work with. And then onto that next slide. Types of data engineers. So you have many types. It really depends on the size of the organization they're working in. So you can have a generalist, pipeline-centric, or database-centric data engineer. A generalist is typically found in a smaller organization. So they're one of the only data engineers. So they're wearing many hats. And because of that, they're just doing lots of things, but they're known as a data-focused person in that company. A pipeline-centric data engineer is often in a mid-sized business. So they're pipeline-centric, meaning they're working alongside data scientists to help make most of the data that they collect. And they need to have an in-depth knowledge of distributed systems and computer science, whereas a database-centric data engineer is in a large organization where managing the flow of data is a full-time job, and they focus on analytic databases. Database-centric data engineers also work with data warehouses across multiple databases, and they're responsible for developing table schemas as well. So it really depends on what size organization they're working in terms of how you would classify that data engineer.
And I think a lot of that holds true to data science as well. So I think if you look at a lot of the scale-up organizations where they start, they'll probably look at someone that understands data science and data engineering, and then over time they'll specialize out in the team. So it's very similar to what you do in mobile, where you probably would start with React Native and hybrid, and then over time you would then diversify it out to native languages.
Sure. Awesome. So then the evolution of data engineering. Now like I said, we will send this over afterwards, but essentially we've gone from traditional ETL to real-time streaming ETL, which again is that extract, transform, and load process. So the current state combines low latency of replication with transformation capabilities of ETL and performs inline transformations in memory, and it's designed to support varied sources and targets. In terms of key technologies that are used, so there's quite a few. So you've got Apache Hadoop, which is a foundational data engineering framework, which is used for storing and analyzing massive amounts of information. You've got Apache Spark, which is a Hadoop-compatible data processing platform. Unlike MapReduce, it can be used for real-time streaming. It's also 100 times faster than MapReduce. You've got Apache Kafka, which is the most widely used data collection ingestion tool, easy to set up, easy to use, which is why people lean towards it. And it's high-performance platform that can stream large amounts of data. And then you've got databases. So like you've got SQL and non-SQL. So you've got relational, non-relational, as Darren mentioned, but we will be touching on this in more detail in a session on Monday.
Yeah, I would say that if you're looking at database, if it has SQL at the end of it, it's going to be a relational database. If it's got DB at the end of it, it's going to be a non-relational database. That's never been specified. It's not something that's written in stone, but I've always seen it as the case. I can't think of many examples where it's not I can't think of any examples where it's not the case. But if someone knows it is the case somewhere, please do shout it out and correct me.
Awesome. Yeah, just some additional technologies used. So you've got these three back-end languages, so Python, Java, and Scala. So Python is very popular general purpose language. It's used for statistical analysis tasks. You've got Java, which is used for its high execution speeds, and then also Scala, which is an extension of Java. It's a JVM language, so it's built on the Java virtual machine, and it's commonly used with Spark because Spark is written in Scala.
Cool. And then AI. So I think on the left-hand side, that's the assumption a lot of people have when they think about AI. Don't get me wrong, AI has come a long way over the last 20 years or so, but we're not a Terminators. Like they aren't thinking on their own. What AI is and we'll touch on it actually in a minute, but AI is basically a computer that is looking at millions upon millions of transactions and looking at what should be the outcome. So if you look at the left-hand side, we've got Terminators. On the right-hand side, you've got IBM Watson, which won Jeopardy. And I'm sure that people have seen this example before. If we look at the history of AI, so at the start of AI, you've got the Turing test. For anyone that doesn't know what the Turing test is, it's basically a guy called Alan Turing, and what his test does, it says, can someone work out whether this is a human or a computer? If you can't work out the difference, then it's past the Turing test. We then had a couple of years where a bit of stuff went forward. So AI was kind of born in the 1950s, and then in the late 60s up to about 97, we went through what we call the AI winter. So we'd reached a point where we couldn't really go any further from an AI perspective because computers weren't strong enough. So we hit a kind of winter at that point. You then get Deep Blue. What Deep Blue was, it was a IBM system which defeated a grandmaster in chess. So that was the first time in a long time that AI had taken a leap forward. As we go down, these are some of the bits that are probably recognizable. So people of a similar age or older to me will remember these Sony dogs that you used to see on TV all in around Japan. You've then got the Roombas. I own one myself. I don't think they're as smart as they make out they are. It's ended up collecting stuff and then getting stuck, but they're pretty cool. Siri then gets into the late 2010s, and then I think the one that's very, very interesting is there's one called Tay, which got to into 2016. I think the reason I find Tay fascinating is it shows both the power and the danger when it comes to AI. So what Tay was, it was a chatbot that was released onto the internet, and the whole point was that you could send it questions and it would give you an answer. The problem was they released it to such an extent that it scrolled through and went through millions upon billions of pages and went through human history, and within an hour it became racist and anti-Semitic because all it was doing was looking at what other people had done, what other people had said before, and it got to the point where it was out of control. So AI has to be controlled in order for it to be effective. If you just let it go wild, then stuff's going to go wrong. That's why, from a banking perspective, a little bit different, but from a banking perspective, when it gets to recommendations of what you should do, you have to have a human involved in that process. You can't allow a chatbot to recommend stuff like mortgage rates and banking decisions because the chatbot isn't really thinking like a human. All it's looking at is billions of transactions that have happened and then giving you some recommendations. So when it comes to very complex decisions that should be human led, that's when you would take AI out and you bring humans back in. We're going to go through a couple of different methodologies here. So deep learning is basically a technique that teaches computers what comes naturally to humans, so learning. So what we're looking at from this side is stuff like driverless cars. So everyone's probably seen those Google cars, and what we're allowing them to do is recognize a stop sign or distinguish a pedestrian or a lamppost. So similar to what a Roomba does to much of an extent. Over time, it will start looking at what it expects to happen. It will see, right, okay, this image here is human, so therefore I need to stop, or I need to make a left because this is what the map is telling me. And when the data is coming into the Google car, a lot of people might think that it's the image. Really, it's millions of pixels of data that then creates an image. They're not looking at the image like we would from our eyes. They are taking the data that it comes out of it, They were then analyzing that data, and then they're building it back out in microseconds into a picture that makes sense and they can make a decision based on. You've got computer vision, which is another field which is looking at digital images. Again, it's very similar, and you'll see some crossover between them. Very similar to what we're looking at from this side, but some of the examples in real life is Google translates and lets users point a smartphone camera at a sign in another language, and then it automatically then obtains a translation in the sign and then makes prediction. I think the best of what I've seen from computer vision was, I believe it was in Taiwan when COVID first hit, and how they're using it from a Taiwanese government perspective is they were looking at the cameras on the street, and they were looking at the distance between people. So they were looking at objects and saying, right, okay, that's a human, and then they were then predicting how much distance was between them. And if they were too close and weren't following social distancing, they would then get police officers to go and separate them. So it was really, really effective in some of the Asian countries to avoid the spread of COVID. NLP, so it's a branch of computer science, and it's specifically looking at how can a computer understand text and spoken words in a way that human beings can. Again, what NLP isn't doing is looking at actual words and understanding them. It's breaking down into different transactions and then making predictions based on it. You won't even realize it's happening, but when we're looking at email filters and predictive text, that's essentially what NLP, I can never get that acronym out. So when we're looking at email filters, it will look at certain words and say, right, okay, should this be a primary, should this be a social, or should this be a promotion email? And then it will go into your emails based on that. Most of the time it works. I'm sure that we've all had ones that have gone into our junk that they shouldn't have gone into our junk. Unfortunately, because of hackajob name, sometimes that happens with us. But yeah, that's what essentially the email filter is doing. And then predicted text, it's looking at, if your email is darren@hackajob.co and I put in hi, it's saying, right, okay, the email's Darren, you're probably going to say hi Darren next. And it's looking at what you've previously said in the way that you've spoken to people before, and then it's predicting what you're going to say in the future. Neural networks are a way, it teaches computers to process data in a way that is inspired by human brains. So essentially it's an ML process, but it's looking at how would a human say something, or how would a human do it. So it's deep learning basically, and it's looking at interconnected nodes and neurons and layer structure resembles the human brain. So this is as close as you get to a human brain from a AI perspective. So what we're looking at here is like house pricing predictions come through that. So it's a combination of deep learning, neural networks, and then it's predicting the house prices given like areas or cities, and then it's pushing stuff up and down. So when you're looking at house prices, a lot of time the decisions we made as much based on what's been sold in the area as what it's seeing out there. So it's scrape through the internet and say, right, okay, a human would probably put it at this level, this is what we should do at. AI robots, I saw one of these in Times Square last time I was in Times Square, the most amazing thing I've ever seen, to be honest. But AI robot is very similar to a Roomba, like I say. So it's gathering information based on the situations it's had before and sensors, and then it is then making decisions on movements. So the prime robots are using a combination of computer vision, because it's looking at, okay, is there a human in front of me? Is there a road? When do I need to stop? But it's also looking at what's happened before. So it might say, right, okay, as I'm going down this road, previously the robots that have been on this route have found that they go into loads of human traffic when they're going down a certain road. So our prediction is that going this route, despite not being the fastest by how the crow flies, is the quickest route to get to the destination. Then recruitment insights, like I said, there's only two of the four normal ones in here. If people want the other two, please do reach out to me and I can get to you afterwards. But from a data science perspective, 16.1% of data scientists are based out of San Francisco, 12.3% are based in New York, 7% in DC, 6.2% in Seattle, and then 5.6% in Boston. when I looked at this data, I'll be honest, I was very, very surprised given some of the colleges that are in Boston. I expected Boston to be much higher. So that was a bit of a surprise from that side. But interestingly, when I was looking at the locations that there are less jobs than there are, or the equilibrium is lower than there is in other locations, Austin, Chicago, and Boston came up as the big three on that side. From a data engineer perspective, have I gone in the right one? Yeah. From a data engineer perspective, San Francisco is 12.4, New York is 10.2, Chicago is 9, Seattle was 8.2, and then Boston 6.6. And then from a supply perspective, Charlotte and North Carolina came up, Philadelphia came up, and then Boston came up. So Boston seems to be a good place to go out and get data engineers. We're working on a big project for a company that are based in and around Boston who are heavily looking for data engineers, and we found it quite a good area from our own marketplace perspective. So our marketplace is quite flush in that area, so it's kind of holding true from what we're seeing from our side. And that is everything. I've seen there's a couple of questions. I'm just going to unshare my screen because for some reason it's not letting me go into the Q&A. Cool. So my hiring manager will only look at candidates who have commercial rather than academic backgrounds. What's your opinion? So I'll start, and then Nikki, if you want to jump in afterwards. So I think it depends on the reason. I'd say this a lot when speaking to recruiters about what they should do with their hiring managers. So I think my question is always why. Like, is there something in particular that is maybe industry specific that can't then be looked at if they've worked in a non-commercial basis? So it might be maybe it's something e-commerce related that you're unlikely to have done if you are working in an academic setting. Academic settings tend to be very statistical. Maybe they're working on biology and microorganisms, and maybe they're working in physics. So there might be some reasons why a hiring manager wouldn't look at a candidate that is has only an academic background. But generally, I think that it's good to understand the reason behind it, because there might actually not be a reason. It might be bias against candidates. So yeah, I'd always say ask the question and then you can get better understanding.
Yeah, no, I would definitely agree there. We actually had, I'm not sure if you know of this, Darren, but we had an example quite recently where a client came to us and they had a role on the platform and they were only looking for commercial experience, but actually ended up hiring someone from academia, and it's worked out really well. Sometimes I think it's just about displaying the options to a hiring manager, saying, okay, fine, so predominantly we'll focus on someone with a commercial background, but why don't you meet this one person from academia? Because it may just sway their decision. Because ultimately, if it isn't something like Darren's mentioned, where they need an industry-specific skill set, then they may just have the right level of understanding to perform in that role.
Awesome. Cool. How important is a master's degree in data science? I would say that the reason that master's degree, it's kind of a chicken and egg here. It's quite interesting. So I think that the reason that people want master's degrees or PhDs often in data science is because when you're doing a PhD, you oftentimes will be doing a lot of statistical mathematical work. So that's very, very useful in a data science role, because you then get people that have gone the statisticians route, which is obviously one of the ones we touched on earlier. But then you get to the same argument we just had a second ago, where people want someone who comes from a commercial setting. So I would say that it's useful, but I wouldn't say it's an absolute must. If someone is a mathematical genius, but they haven't gone to college for whatever reason, it might be socioeconomic reasons, it might be that they just wanted to go straight into a commercial setting, I would say there's no reason why you couldn't go into a data science role and be successful if you don't have a certain level of degree from college. But I would also say that it doesn't mean that you're not going to be successful if you don't. I would also say that it puts you on good footing if you do the opposite of what I was going to say. Cool. What does Bandit ML do? This is a skill listed in Amazon's product role. So Bandit ML is, as far as I know, is an e-commerce tool to build ML framework, basically specifically for e-commerce. I'll be honest, I would have to look up a little bit more on it. But as far as I'm aware, it's a ML framework that is specific to the e-commerce world. So more along that kind of specialist route than kind of others on there. But what I'll do is I know that I'm connected to you on LinkedIn, so let me do some little bit of research and then I'll ping you on LinkedIn about it. Unless you know, Nikki, you were on mute and then came off mute and then went back on mute. No, cool. Cool. All right, cool. I'll go away and look up that afterwards. Do technical tests matter for data candidates? Nikki, do you want to take this one?
Yeah, for sure. I think yes, I think they do matter. I think we touched on this yesterday, actually, 2 days ago, when we talk about front end. Technical tests generally, I think, are important. I just think it's the way that you're running the technical tests. Is it becoming a blocker in your process? It is making candidates turn away and say, actually, I've got multiple other interviews I'm going for that aren't requiring me to put in this work, or is it something that allows them to learn more about the business? So if it's a session with somebody from the team where they can maybe solve an issue together or discuss how they would look at a problem and interrogate data or something of that nature, I think that's a good use of time because they get to interact with people they may be working with, learn more about how that team works, but also demonstrate their skills. I think if it's that you just send them, a data set, then you ask them to go perform some analysis based on that. I personally, think you may lose some candidates in that sense, but I do think it's important to be able to assess someone's level of skills. But that does depend on what level of seniority they're going in at in the business as well.
Cool. Awesome. I would say from a technical test perspective, depends on what you're doing in technical tests. I think that I see a lot of clients that will do like software engineering tests for a data engineer because they need to have some programming skills. And I think that kind of defeats the point. Like you're not really testing them on their data engineering skills, you're testing them on their software engineering skills. So I think you probably can do that more in exercises on site rather than in a technical test. And I think that take-home tests are always going to be a bit of a problem. I also think that when you look at data science tests, they tend to, again, not be really testing what you're looking for from that side. The worst technical test I've ever seen, to be honest, was one from a telco brand, and they asked you to do 30 questions in 30 minutes. And when I looked at it, it was put out in the sense that if you were neurodiverse, so maybe dyslexic, dyspraxic like myself, or you didn't have English as your first language. So our engineering team are based in Romania. So when you have to then figure it out in a language, then put it back into your own language, you would fail. So data science tests tend to be very wordy. And I think they're just there to be there. I think that people are used to there being a technical test, so therefore people feel like you need one in data science and data engineering roles as well. Whereas I think that practical on-site tests are a lot better. What is a recommender engine? I think that I should say. So a recommender engine is essentially it's similar to predictive modeling, where it's recommending an outcome. So it might be, we're recommending that if someone clicks onto a keyboard, we recommend that they then look at a mouse on like Amazon or something like that. That's basically a recommender engine. But a point on my LinkedIn, so not able to connect, but I'm able to follow. When you go onto my profile, if you click the bit next to follow, you should then be able to connect. If not, follow me and then I'll connect you afterwards. What time is it? Cool. What type of data engineer needs to code the most? You obviously went through data engineering, Nikki, so I don't know if you want to touch on this one first.
Yeah, I wouldn't be able to answer that fully. I think that it could depend on the environment they're in, because if you look at a generalist data engineer, they may have to code tons because they're looking at all different aspects of data engineering. I think it's probably I don't think there's a specific answer I could give. Darren, I'm not sure if you have a different opinion on that.
No, I think that probably holds true to a lot of stuff. So I think that if you look at a lot of different areas, so DevOps, for example, depending on your organization, it'll be more like programming would be more and more important. So it's probably looking at your organization as a whole, do you have specialists so a data engineer doesn't need to do too much programming, or do you have quite a generalist team? Yeah, so it's hard to really say without knowing your organization. Is Hadoop considered old school in comparison to other big data tools? Yes and no. Like, there's other big data tools out there, but I think that it's in a similar vein to like Java, where there's a lot of programming languages that have come along the last decade, 2 decades. But Java is kind of innovated to the point where it's kind of stayed around. Hadoop is very much the same. So Hadoop probably holds about a third of the market when you look at comparable tools. So it's still the go-to when it comes to it's like rivals out there. So I wouldn't say it's necessarily old school, but it's one of the more original ones, if you like. So it's kind of the OG within its own space, but I would still say it's relevant within the market. Any other questions? What type of talking points move the needle for data scientists? Does it differ from talking to software engineers? I'm not really sure I understand the question here. Let me give somewhat of an answer, and if that's not what you meant, please do put something else in there, and I kind of build on top of it. So if we're looking at the talking points when talking to a data scientist within an interview, yes, that what you're looking for there be very, very different. If you're looking at a software engineer, you'd be talking about what applications have they built, how complex the applications they built. If you're maybe a organization that utilize pair programming on the site, is that something that they've been involved with before? Have they got an appreciation for cloud or anything like that, distributed systems, etc., etc.? If you're looking at a data scientist, it's probably looking at what models have they been involved with before, what's the complexity of the data they've dealt with before, because if you look at the complexity of data at, say, eBay, it's going to be much more complex than it maybe would be at hackajob, for example. So eBay would need someone who has dealt with like petabytes and zettabytes worth of data that's going in on a daily basis, whereas probably less so at a small organization. So it's the complexity of the data they're probably looking at would be the main thing on that side. And also, have they built predictive models? What kind of team setup have they worked in before? Because again, as we keep touching on, if you are a smaller organization, you probably need more of a generalist rather than a statistician. So yeah, I think they're probably the talking points you're looking at, like what kind of models have they worked on, what's the complexity of the data. Thank you very much for the kind words. Hopefully you're going to be there for Monday session as well. But I'll leave it one more minute just to see if there's any final questions. Oh, interesting. Nick, I'm going to throw this one to you first. Can someone become a data engineer by only attending a boot camp and then practicing?
Yeah, I think so. I think that it may take them quite a while to pick up the skills and then be able to practice those in a commercial environment. Yeah, I think if they do a good boot camp that teaches them the foundations and the fundamentals, then they take it onto themselves to keep practicing in their own time, then yes, and potentially finding a junior role that will then support them to continue learning, for sure. But I think it just depends on their willingness to continue learning themselves.
Yeah, big shout out to one of the coding boot camps here. So there is, I believe they're called Flatiron, and they've got a really good coding camp that when I was in New York last, I went and visited them, and they have quite a few different programs that they work on. They have more design ones, more software engineering ones, and they've just started doing data science and data engineering. And yeah, it's a really good route from that side. So I would say it depends on what boot camp, probably more than anything else. So are they working with instructors that know this market inside out? Because it's a very, very different market than others. But I would absolutely say that you can become a data engineer without necessarily having gone through the traditional and abbreviated commerce route. Some really good questions today. keep going to end it, and then someone chucks in a lot of final questions. So I'm going to give it. I'm going to say it for a third time. I'll give it a final minute.
I think we've got to give it one more minute. Just
yeah, exactly. I'm enjoying this. I love talking about data. Data is my favorite part. If anyone couldn't tell that I enjoy data.
I can just imagine you now with walls all scratched from your Roomba.
Oh, my Roomba has gone in the cupboard now. I've just resorted to using my my trusty Dyson.
Yeah.
So it don't get much use anymore, because as soon as it hoovers up, which I have a Labrador at home, as soon as it hoovers up Bailey's hair, it then breaks. So yeah, I wouldn't recommend it given your dog as well.
Yeah, but we used to have one, and I found that the sensor that it would use to map out where objects are in the real world was just it crashing into the wall and then turning around.
That's exactly what a Roomba does. Like, it's mapping out your room by bumping into things, which can be really annoying if it's starting to do damage to the paint.
Yeah.
Cool. Right, I'm seeing a few people leave. We've lost about 5% of people in the last minute or so since we've been talking about Roombas. So we're going to end it here. If people want to reach out to me, like I say, connect with me on LinkedIn, connect with me through darren@hackajob.co. I've been on paternity leave for the last 3 weeks, so if you have emailed me, not ignoring you, I promise. I just haven't been looking at my emails, but I'm back in Monday. So please do reach out to me, and try the Robo-Rock apparently instead of the Roomba. So Nikki, we need to get on that. But yeah, reach out to me on LinkedIn or on email. Everyone have a lovely weekend, and I look forward to seeing a lot of you on Monday.
So thanks for joining.
Bye, guys.
Bye.